Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 3, 3.2, and an introduction to logarithms. Logarithms are the inverse function of exponential functions. Logarithms have what's called a base. So, for example, if we had log a of n, that would mean the logarithm to the base a of n. How are logarithms defined? Well, because they're the inverse function of exponential functions, they are defined in terms of exponential functions, and that is the way you should understand them. So if we had the exponential function, a to the power of x is equal to n, and then we took log to the base a of both sides, then we'd obtain log to the base a of a to the power of x is equal to log to the base a of n. And it's what happens here on the left-hand side that is important. Log to the base a is the inverse of a to the power of. What that means is if we have both of them operating together, like we have here, they just cancel each other out. Now, that's the same as if we had 3 times by 5 and then divided by 5. Times by, divide by, they're inverse functions to each other. So if we times by 5 and then divide by 5, the two things just cancel each other out. Or if we had a number plus 10 and then took away 10, add 10, take away 10, they're inverse functions to each other. They just cancel each other out. So these two things cancel, and all we have here is x equals log to the base a of n. So that's where we started from. That's where we finished. Just combining those two things together gives us the relationship between exponentials and logarithms. And it works both ways round. So if a to the x is equal to n in exponential form, in logarithmic form, saying exactly the same thing is log to the base a of n is equal to x, or working the other way round. And that is one thing that you have to be able to do. Just change from logarithmic form to exponential form, or back the other way, from exponential form to logarithmic form. Let's have a look at how you do that. So example 1, we've got an exponential statement, 4 squared is equal to 16, and we're asked to write that exponential statement in logarithmic form. Now, I'll let you have a go at doing that yourself first, see if you can make sense of this. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. Now, we've got an exponential statement here in that form. What I'll do to make things absolutely clear is say what all of these letters stand for in this question. So A will be 4, X is 2, and N is 16. And we're just going to take those three values and substitute them into the definition of a logarithm. So in logarithmic form, 4 squared equals 16 is equivalent to log to the base 4, because A is 4, of 16, because n is equal to 16, is equal to 2 because x equals 2. So that's the statement in exponential form. That's the statement in logarithmic form. Okay, example 2. 3 more questions exactly like the one we just did. So in each case, take the exponential statement and try and write it in logarithmic form. Pause the video, have a go, come back to me when you're ready. Okay, let's have a look at these 3 questions. So 7 squared equals 49 is the exponential statement. In this case, a is 7, x is 2, and n is 49. Just substituting those values in on the left-hand side, we get 7 squared equals 49 is equivalent to log to the base 7 of 49 is equal to 2. The second question, 3 to the power of 5 is 243. A is 3, x is 5, and n is 243. Substituting those values in logarithmic form, 3 to the power of 5 is 243, is equivalent to log to the base 3 of 243 is equal to 5. And the third one, 64 to the power of a half, which means the square root of 64 is equal to 8. So in this case, a is 64, x is a half, and n is 8. So in logarithmic form, the exponential statement would be equivalent to log to the base 64 of 8 is equal to a half. So that's changing in the one direction, changing from exponential form to logarithmic form. What we'll try and do now is move back the other way. So you've got three statements written in logarithmic form, and this time you have to write those statements in exponential form. Again, I'll let you have a go at doing this yourself first. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So the first question, we've got log to the base 2 of 1024 is equal to 10. Now, you may find this helpful. The way I tend to think about things when I'm converting in either direction, actually, is left, right, middle. And what I mean by that, the left number is 2, the right number is 10, and then you end up with the middle number. So 2 to the power of 10 is equal to 1024. That's really the easiest way to read a logarithmic statement in terms of what it's saying. It's saying 2 to the power of 10 takes you back to the middle. You get 1024 for the answer. And that's the exponential form. So 2 to the power of 10 is 1024. Otherwise, we could do what we did on the last example, write down explicitly what is a, what is n, what is x, and then substitute this into the exponential form. Second question, log to the base 125 of 5 is equal to a third. Now, what's that saying in terms of powers, exponentials, is that left, right, middle, 125 to the power of a third will give us 5 for the answer. Now, a third is cube root. So 125 to the power of a third means the cube root of 125, and the cube root of 125 does equal 5. So writing it in exponential form, that's what we'd say. 125 to the power of a third does equal 5. And the last one, we've got log to the base 64 of 1 over 8 is equal to minus a half. Now, again, just thinking left, right, middle, writing that in exponential form means 64 to the power of minus a half is equal to 1 over 8. Half means square root. The square root of 64 is 8. The minus means we're going to do reciprocal, 1 over. So we get 1 over 8. So that does make sense. Okay, without using a calculator, by converting these to exponential form, have a go at working out the exact value of log to the base 10 of 100, log to the base 2 of 32, and log to the base 27 of 3. So these logarithmic statements, we'll quickly convert them into exponential form, and then just by looking at them and using common sense, find what value they have. I'll let you have a go at making sense of that. So pause the video, have a go, and come back to me when you're ready. Okay, question 1, log to the base 10 of 100. Now, what I'll do first of all, and this isn't particularly obvious, is you'll notice we don't have an equals x in the statement. It does actually make things a little bit simpler to see what's going on if you do include the x. So we're trying to find the value of this. The value of this is equal to x. Adding the equals x does mean it's just written in the standard form, and you can think about it in the normal way, which is left, right, middle, which means 10 to the power of x will give us 100 for the answer. And then you're just thinking, well, what power of 10 will give me 100 for the answer? Well, 10 squared is 100, so x must equal 2, and x is the value of log to the base 10 of 100. When we read that statement, and they say, what is the value of log to the base 10 of 100? You can just get straight there. 10 to the power of something is 100, and that's what the answer equals. So question 2, log to the base 2 of 32 is equal to x. Again, you could just say 2 to the power of something is 32. And writing in exponential form, that is what you get. 2 to the power of x is 32. What is x? Well, 2 to the power of 5 is 32. So x is 5. So log to the base 2 of 32 will equal 5. And example 3, log to the base 27 of 3 we've been asked to find. 27 to the power of something will give us 3 for the answer. So writing in exponential form, that's what we get. 27 to the power of x is equal to 3. The question is, what is x? Well, the cube root of 27 is 3. 3 times 3 times 3 is 27. Therefore, x is equal to 1 over 3, and that would be the value of log to the base 27 of 3. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 53 and have a go at exercise 3B. Thank you very much for listening, and cheerio.